Right, good morning. I think there's at least one viewer logged in already or waiting to log in. There's going to be 10 minutes. I'm going to put a 10-minute timer on. And again, that's that 10 minutes to log in and so on. I'm also going to set up the Socrative now. So if you go to socrative.com, go into 72249, it might say it's waiting for the teacher to start the next activity, but I'm about to start that next activity. So I'll put 10 minutes on the clock, and that's a 10-minute countdown till the lesson will begin. And you'll just see me getting things ready, and every so often I'll welcome new people in as they come. 2 people in the room now, so thank you very much. Very nice to see you. Hi, Matthew. Hi. Right, so those joining, there's a couple already. You can see my computer's on a bit of a go slow, at least my second computer. I hope that's not ominous as to the internet signal I've got here today and suggestive that we're going to have some problems. Let's hope not. But when I log in now, you can log into, you go to student login. I'm clearly going to do the teacher login and type in 72249. You don't need to wait for me to log in. You can log into that anytime. It will just say something like waiting for teacher to start the next activity. As soon as I've started that activity, actually the first question will pop up, and anyone who's logged in, feel free to answer that first question while you wait. Real slow progress with the internet at my end, hopefully that's only true for me, and it would help if I put correct email addresses in. There we go, I seem to have logged in now. We'll start the quiz in roughly 6 minutes time, but I will wait for the numbers to sort of work with each other. So if there's 4 people watching, I'll expect roughly 4 people to have logged in here. I'm going to start the quiz now. So if you've already logged in, you should see your screen change in about 30 seconds time. I can see 2 of you in the room already, so thank you for that. So unlike last time, I'm setting the quiz. You should be able to see your final score at the end. That's certainly my hope. But I'm going to paste the quiz once again, so you won't be able to navigate till the next question until I navigate to that next question. It just worked well last time. And so there'll be some waiting for those of you who answer questions quickly, but it worked perfectly fine last time, as I say. And anywhere the answer requires some going through, especially if lots have got it wrong, then I'll go through much as I did last time. Anyway, with all that said, I've launched the quiz now, and so you should be able to answer that first question whilst you wait. So there's 3 or 4 people logged in on the Socrative, there's 4 or 5 people watching on the screen, so those numbers are nearly adding up. And in roughly 4 minutes time, although we'll wait for stragglers if we think there are going to be some, in roughly 4 minutes time, we'll start the quiz. Hello as well, Max. Sorry, I didn't see your hello in the comment there. Just shuffling the camera a bit. More central, there we go. So the quiz is up and running. There are 3 or 4 students in the room. If you're not seeing the quiz up and you know you've logged in, then click refresh, and that should be all you need to do. You can always try going out and logging back in on 722249. But either way, you should be able to access this question. It seems to be working for the 3 or 4 who already have done actually now. So we have all of you have answered, I think, who can answer at the moment, which is good. Thank you for your patience if you're waiting. I think there's still some people waiting to log in, just judging by the numbers I'm seeing on screen. I think there are still some people to log into Socrative as well. In about 2 minutes' time is the official start time of the quiz, so we've still got a little bit of waiting time ahead. There's now a little bit of disparity between people watching on YouTube. So there could be some people who have just logged in on YouTube, haven't yet on Socrative. Just look at the comments for how to do that. You go to socrative.com, like last time if you played along last time, socrative.com, student login, and then go to 722249. 722249 is my sort of Socrative classroom where I can set assignments. Well, I think with that we'll start. There seems to be a steady number watching on the stream. There seems to be a steady number logged into the classroom. I can't quite tell how many are logged into the classroom. There is some disparity with what I see on my screen. I think everyone who's answered can answer, so I'm just going to pause one final moment as I make some sort of introductory instructions. Whilst I'm doing that, if you haven't answered the question yet and you know you signed into Socrative, then please do so. And my last call out on that, if anyone has just tuned in, is that you go to socrative.com and then you go to student login and then you log in with the number 722249, and that will take you to my classroom where I'm setting this quiz. Well, the first thing I'm going to do is actually address the children of the near future, and by which I mean, if you're not watching this live, don't worry. So thank you to everyone who is watching this live, just to address the children of the present for a minute, but now to the children of the future again. You can still do the Socrative quiz. So I'd say for about a week after this date, this being the 15th of May, I struggled there for a minute. It's the 15th of May today, so I'm going to leave this quiz up for about 7 days, for about a week. And at any time, if you want to catch up on the video and answer that, you can do. And in fact, you don't even have to watch the video if you're doing this in retrospect. You can just go to the quiz and go through it. I'll set it in such a way that you can take it at your own pace. You don't need to wait for me to advance things, so you can do it as you wish. But for those playing along now, we'll play along now. So yes, I do have every answer that I can do here now, so we can go through the questions as well. So question 1 was, what will a star the size of the sun turn into at the end of its life? And I suspect, although I'll see answers in a minute, I suspect lots of you will have been torn between 2 answers. We'll see how you did. 4 possible answers: red giant, red supergiant, white dwarf, and black dwarf. The answer I was looking for here, which 75% of you got, so well done, is that it will turn into a black dwarf. I would have forgiven you for choosing white dwarf there. But actually, as a white dwarf cools down and emits less and less radiation, it sort of goes through the colour spectrum until it's not really emitting any light at all, and then it's known as a black dwarf star. So yeah, a star the size of our sun will end its life that way, as a black dwarf. A red giant is actually the next phase it's going to go to. So it's currently on the main sequence. It's currently in its stable phase. It's been there for about 5 billion years. It will be there for another 5 billion. But in about 5 billion years' time, there'll be a last perfect day on Earth. And then the sun will start to expand. In its death throes, a star actually gets bigger for a time. And when it does, it becomes what we call a red giant. So well done to most of you on that one. Next question. Which of the following statements is correct for a loudspeaker? Choices are these. An input of sound waves is transferred into an electrical output. Loudspeakers only work with DC input. An electrical input is transferred as an output of sound waves. Or loudspeakers make use of the generator effect to convert changes in current to sound waves. All sound very plausible. Which of them is correct? I'll give you a moment to answer now. Three of 4 answers so far. Nearly everyone in, I think. I think waiting on one more answer. I'll just wait a moment to see if a 4th answer does come in. If not, we'll go through it in just a second. Right, I'll go through the answer. Just whilst I do, apologies if, and I suspect it was quite loud then, there's some road resurfacing going on just outside where I live. And so there's quite a lot of heavy machinery and vehicles and sounds associated with that, very close to where I do these from. So sorry if that intrudes on the sound and the quality of what you're hearing. Right, we do have all answers in now. So yes, which was true for a loudspeaker? Well, let's see how we did first. And again, a 75% hit rate, as it were, on this one. They were all ones that felt plausible. Someone got caught out thinking it was answer D. Well, answer D says it makes use of the generator effect. Now, think about that for a minute. That bit is fine. That bit would be true for a microphone. A microphone makes use of the generator effect because the movement of your own voice and the pressure wave in the air makes the diaphragm of the microwave vibrate, and microphone vibrate. And out of that comes an electrical signal. But this is a loudspeaker. Loudspeakers, in fact, make use of the motor effect. So they take the electrical signal and they convert it back into a pressure wave. And so D was nearly correct, but not quite. It's C. An electrical output is transferred as an output of sound waves. Well done if you got it. Next question. And I think this quiz is hard at times. And one thing I should have said is do have a calculator ready and a piece of paper to do calculations if you need to. For example, this question. What is the value of the force F needed to balance the seesaw below? So you should be able to make bigger possibly, or at least focus in on that picture. What force is needed to balance that seesaw? I'll give you a moment to answer that, and we'll go through it as you're answering. I'm going to practice as I preach and just grab my calculator so I'm off screen just for a minute. Well done if you've answered already. I think there's some swift words, some swift physics if you have. Just waiting on a couple more answers. Still waiting on a couple of answers, so thank you for your patience if you've already done with it. I'm going to take this off, I don't need the timer anymore. Right, we have all answers in now. So before I launch into a big explanation, let's just see how you did first. I'm really impressed. I do just want to draw your attention to one thing. Now, you might have done that, and you'd be right to, by the way, by calculation. Moment equals force times distance. This is a question about turning effects, about moments. This was one you could actually do, and in science and maths we call it proof by inspection almost. You can see the answer to this by inspection. In other words, if you look at the seesaw on the left-hand side, well, it was a shorter distance away from the pivot and it required 600 newtons. There's only one answer when you look at it that makes sense for the force on the right-hand side. A greater distance means it needs a smaller moment, and there's actually only one possible answer that's smaller than 600, the answer you all gave. So I don't know how you solved it. You might have done it by calculation. Great if you did. Just occasionally in physics, you can look at something and see the answer by inspection and get there quicker. And this was one of those. Next question. Which of the following statements about transformers is not correct? We're looking for the statement that's not correct. Choices are these. Transformers can be used to change the size of an alternating current or voltage. Transformers only work with a DC input. Transformers only work with an AC input, or step-up transformers are used to increase voltage. One of those statements about transformers is not correct. I just need you to identify which. Got nearly all answers in. I'm just going to wait a moment. Pausing briefly, I think I'm expecting one more answer to come in, so thank you for your patience if you've done. No, I'm not. They're all in, so thank you, everyone. Let's see how you did. Which of the statements about transformers was not correct? 100% well done. Yeah, transformers only work with AC, they don't work with DC. Lovely. Next question. Another one where you might need a calculator, so I have that handy. We have a picture of a before and after collision. So we have a collision before and after carts A and carts B. And it says before the collision, trolley A has a mass of 1.5 kilograms and a velocity of 4 meters per second. It is moving towards trolley B, which is stationary and has a mass of 2.5 kilograms. The two trolleys join and move off together as shown. What will the velocity of the trolleys be after the collision? Four choices: 0.8 meters per second, 1.2 meters per second, 1.5 meters per second, or 2.4 meters per second. Let's see how you do. I'll give you some time to work out your answer on that one. Half of you have answered, half of you still to answer, so just be patient if you're in that first half. I'm just going to try a noise abatement strategy. I suspect you can hear the trucks. There's just a door I can close, which should help. Right, we have all answers in. I think there's a lot of tough questions on this quiz, so if you're already feeling like you're struggling, please don't worry. Let's see how you did on this. First one to have split the room 50-50. So I'm going to go through this one. It doesn't take too much going through. And once you know how to do these, as with all physics, really, it's easy when you know, but until you know it, it really isn't. So we had 2 trolleys. I'm just remembering these numbers for myself as I move away from my computer. 1.5 mass on the first one, 2.5 mass on the other one. It was moving at 4 meters per second initially. So yeah, the before picture was laid out, but I think it's always, when I'm solving something like this, and maybe you did on your pieces of paper at home, I tend to draw them out with all the correct numbers in place. So cart A had a mass of 1.5 kg, and it was traveling at 4 meters per second. Cart B was stationary, and it had a mass of 2.5 kilograms. That was the before picture, and we were told that in the after picture, these 2 carts moved off together, cart A and cart B. So I hope you can see, and I'm not quite laying it out as I would on a piece of paper. There's now a combined moving mass. Before there was only 1.5 kilograms of moving mass, but now this has crashed into that one, and they've been shunted down the road. And so these have a combined mass now of 4 kilograms. That's 1.5 plus 2.5. Well, we can now use the momentum equation, because there's a key idea with momentum, which is that however much momentum you had before will be the same as the momentum you have afterwards. So you had a total amount of momentum before. Well, let's find out what it was. The momentum before, that one wasn't moving. That one didn't have any momentum. So all the momentum in this system was from this first cart and its movement of 1.5 times 4. Mass times velocity. Momentum equals mass times velocity. 1.5 times 4 is 6 kilogram meters per second. That's not the final answer here. We're being asked to find out the velocity afterwards. And the law of conservation applies here. If you had 6 kilogram meters per second of momentum beforehand, then this still has 6. So you reuse the equation. So we're using the P equals mv equation again, but we're putting the numbers where we know them. We know that momentum was 6. So where P was, we put that 6 equals, we know M, 4 times by V. When you do that, you realize that V is 6 divided by 4, which equals 1.5 in this case, meters per second. 1.5 meters per second, hence the answer C. I hope if you were amongst those that didn't get it right, I hope you know where you went wrong. I hope that explanation helped. Really well done if you did get it. Next question. Fleming's left-hand rule, this question's about. Which of the following rows correctly shows which fingers on the left hand indicate which variable? You've got a table to look through, and you simply choose A, B, C, or D. See which you think is the correct combination of what finger means what on the left-hand rule. I'll just wait for you all to get your answers in. Yeah, casting your mind back to some of the stuff we've learned remotely now. Fleming's left-hand rule. couple more answers still to come. Nearly there, I think. Yes, we are. Right, let's see how you did. So one of these rows correctly showed what finger means what on Fleming's left-hand rule. 50-50 here, so we've had some slip-ups on this one. It is row A. So with Fleming's left-hand rule, remember that the hand is orientated like this. And the thumb represents the motion. So this might be a wire in a magnetic field, and it feels a kick in a certain direction. Thumb represents the motion or the force. You can use either word. The first finger represents the magnetic field, the direction pointing north to south of the magnetic field. And then this, the second finger or the middle finger, depending on how you want to view it, the second finger shows the electric current. So you have motion, field, current. Unlucky if you got that one wrong. Tough quiz, this one. I will sort of keep giving that warning. Don't worry if you are getting ones wrong, you will get plenty of others right, but it is a tough quiz. Next, a car traveling at 20 meters per second is brought to rest over a time of 4 seconds. What is the acceleration of the car? Your choices on this one are 5 meters per second squared, minus 5 meters per second squared, 10 meters per second squared, or 80 meters per second squared. Still a few answers to come in. Right, let's see how you did. Mostly correct. I think one person has gone about it with basically the wrong mathematical operation, sort of a 50-50 here. Acceleration is change in speed divided by time. Now this was brought to rest, so the change in speed was 20, it's ended up at 0. So there's been a negative change in speed, and that comes in handy with choosing which answer must be right. And it happened in a time of 4. So you're basically dividing 20 by 4. Although actually you're dividing minus 20 by 4 if we're being really strict with this. Acceleration is a vector. Direction matters. And this is something that's slowing down. Sometimes we call it a deceleration. So you could say the deceleration is 5, but this question was about the acceleration. And so the acceleration was indeed minus 5. Minus 20 divided by 4 is minus 5. Well done if you got it. Next question. A ball of mass 6 kilograms is moving at 2 meters per second towards a stationary ball of 4 kilograms. The moving ball stops when it hits the stationary ball, and the stationary ball moves off along the same path. What will the speed of the 4 kilogram ball be after the collision. Read that one carefully. Read that one carefully because I think you've got to treat this carefully. I possibly again suggest that you actually draw this out to help you solve it, but I'll give you a few minutes to solve this one and I'll wait till all answers are in before going through it. Choices are 2 meters per second, 3 meters per second, 4 meters per second, and 6 meters per second. Two answers in so far. Well done if you've been quick on the mark there. 3 answers in. Waiting on one more answer. I'll just wait one more minute for the final answers to come in. All answers in. Let's see how you did. That is absolutely superb work. You can see I was poised. I was poised to go through this. I thought it was a difficult one because this ball, one ball hits the other. And normally we used them moving off together. Not in this case, it loses all of its momentum and all of its momentum is transferred into the second ball. I thought that would catch you out. It didn't. That's really well done. Next question. Which of the following does not affect the reaction time of a driver? Which of the following does not affect the reaction time of a driver? Choices are alcohol and drugs, tiredness, the mass of the car, or distractions. One of those does not affect the reaction time of a driver. Select which one you think it is. One answer still to come in. Just while I'm waiting for that answer, I saw an email ping up. I'm just going to check there's not one of you telling me there's a connection problem or something, so just bear with me one moment. No, no such issues. No. So I'll just wait a little moment more for our final person to answer this one. I think it could be, I think some people receive this far quicker than others. It depends on many things. We've all answered now according to my screen. I also think my internet's a little slow today, so sorry if you've answered ages ago and it's that I've just been waiting for it to filter through to me. Everyone got that one right. Really well done. Yeah, a massive car is an independent when it comes to the effect on the reaction time of a driver. Really well done. Next question, question 10. Which of the following best describes Newton's second law of motion? We learned of his 3 laws. Here are the choices. Forces that act on interacting bodies are equal in size and opposite in direction. B, a body will remain at rest or continue in a straight line at a constant speed as long as the forces acting on it are balanced. C, work equals force times distance. Or D, force equals mass times acceleration. One of those best describes Newton's second law of motion. Choose which you think it is. Right, everyone answered. Let's see how you all did. I thought this might happen. At least one person has fallen into the trap. This question was harsh because actually all of Newton's laws were in the answers. So the one that one of you has chosen, B, is one of Newton's laws, but that's actually his first law. This idea an object will carry on doing what it's already doing unless a force acts on it is Newton's first law. Newton's second law is summed up by an equation, F equals ma, force equals mass times acceleration. Well done if you got that. Next question. A man stands on a concrete floor. The gravitational pull of the Earth on the man is one force acting on him. Which other force makes up the action-reaction pair in this case? I'll give you a moment to choose your options. I'm about to let the cat out of the room. She's waiting patiently. But A is the reaction force of the floor pushing up on the man. B is the force of friction acting between his shoes and the floor. C is the gravitational pull of the man on the earth. And D is the force of air resistance when he starts to move. I think a tough question, but let's see how you do. 2 people have answered so far. There you go, Rex. Well, we've got 4 answers. Very swiftly answered too. I'd be surprised if you'll get this right, but I am occasionally, in fact often, wrong on such assumptions. But, well, you all got it wrong, and I somehow suspected you might. And to be fair, that's because I'm about to go into a distinction which really only comes into play at A level. So let me just show you what I mean. We've got a man standing on a concrete floor. Well, that is within my artistic capability, I feel. So what I'm saying really is that the reason you all got it wrong is me. But I will explain further. So there's our man standing on a concrete floor. And we have done diagram after diagram that looks something like this. You have the gravitational pull of the man. Well, we call that his weight. So I normally label it on the man. I'm going to label it here. We have his weight, W, pulling downwards. And yes, we have done diagram after diagram saying that the reason that man doesn't sink into the floor is because there's a reaction force upwards. I'll call it alpha reaction. You could call it the normal contact force. So that is what I've taught you. And it's not that what I've taught you is wrong. It's that there's actually more going on. There's not two forces happening here. There are, in fact, four. And I'm just going to redraw my diagram to show you what I mean. There are two pairs of forces acting, but to see them both, we need to zoom out. So this time, our diagram has the whole Earth on it. There's planet Earth, and not quite to scale. Here's our man. Two pairs of forces act here. From the center of gravity of the man, there is a downward force. We'll call it his weight. But the very weird thing about gravity is that, yes, this planet Earth has much more gravity than the man, but the forces of gravity are equal and opposite. So if the man's pulled down by gravity, it is a fact that he has a tiny pull upwards on the planet Earth. That's why the answer was C, is the gravitational pull of the man on the Earth. In other words, from the center of the Earth, there is a kind of a pull up in the other direction. So they're the one pair of forces, and what they cause, because there is a surface underneath that man, they cause a second pair of forces to act, a pair of contact forces, in fact. So there is a contact force downwards, man on Earth, and there is a contact force upwards, Earth on man. So that's alpha reaction, it's meant to be anyway. So what you have actually acting in something like this is four forces. A pair of gravitational forces, equal and opposite, and a pair of reaction forces, one pushing down on the ground pushing up on the man. When we teach you physics at GCSE level, we often simplify that, and I think you can see why it is complex. We simplify that to just show the two pairs of forces that sort of matter in the moment. But there are in fact two pairs, not just one pair of forces, but two pairs acting, and it is them. I hope that's clear. I hope you're not too annoyed at me for teaching you wrong. I meant to. Next question. Which of the following correctly explains what happened when white light is incident on a green filter? That's another thing we learned in the very last days that I was still teaching you. Here are the choices. Green light will be absorbed and all other wavelengths will be transmitted. Or green light will be transmitted and all other wavelengths will be absorbed. Or white light will be transmitted by the filter. Or no green light will be transmitted and the filter will appear black. One of those describes what happens when white light shines through a green filter. Make your choice. Four answers in, let's see how you did. Superb. Yeah, green filters only allow green through. Really well done. Next question. What is meant by the term perfect black body in physics? Either A, a perfect black body is a perfect emitter of radiation. B, a perfect black body is a perfect absorber of radiation. C, a perfect black body is a perfect reflector of radiation. Or D, a perfect black body is a perfect absorber and emitter of radiation. A, B, C, or D? Couple more answers to come in. All answers in. Let's see how you did. Half and half. Now, those who put B, it's not that you're wrong. The black body is a perfect absorber of radiation, but it's also a perfect emitter. So A and B were correct, just not completely correct. D is the one that is completely correct. A black body is a perfect emitter and absorber of radiation. Well done if you got it right. Commiserations if you got it wrong. Right, we have a distance time graph for this one. You can make it big or at least click on it. It might not make it that big depending on the screen you're on. Which statement is correct based on the distance time graph for the moving body shown below or shown opposite? A, the maximum speed of the moving body is 200 meters per second. B, the maximum speed of the moving body is 800 meters per second. C, the body is stationary for most of its time on the journey. Or D, the average speed of the moving body is 160 meters per second. One of those is true. Work out which. Couple more answers to come in. Right, 4 answers in. Let's see how you did. Most getting this right. The body was stationary for quite a long time in its journey, but that word most probably means more than half. And in this case, it's only stationary for 4 seconds and the whole journey lasts 10 seconds. So it's not quite half that it's stationary for. Yeah, the average speed is 160. It traveled 1,600 meters. It did it in 10 seconds. 1,600 divided by 10 is 160. Total distance divided by total time will give the average speed on a graph like this. Next question. Which force is responsible for keeping planets moving in circular orbits? Choices: magnetism, the electrostatic force, gravity, or friction. Which of those 4 forces is responsible for keeping planets in orbit? Make your choice. Four answers, 4 correct. Really well done. Next question. Which of the following statements is true for forces? A, gravity is a contact force. B, air resistance and the normal contact force are examples of contact forces. C, friction will act on bodies that are separated by a distance. Or D, The electrostatic force only acts when charges are physically touching. One of those is true for forces. You just need to identify which. Make your choice. Let's see how you did. All answers are in. I think possibly deceptively tough, but I'm wrong. You all got it. I thought air resistance might trip you up, but absolutely air resistance is a contact force. So well done, everyone. Next question. What is the size of the resultant force acting on the body below? So you've got a picture of an object with forces acting upon it. Is the resultant force 20 newtons to the right? Is it 20 newtons to the left? Is it 10 newtons to the left? Or is it 10 newtons to the right? 4 choices, make your choice. All 4 have answered. Let's see how you did. Just a left-right thing there. I suspect someone just made a slip thinking it went left-right in the choices. But now 10 newtons to the left is right there. Well done if you got it. Next question. A motorcyclist covers a distance of 3 kilometers in 5 minutes. Which of the following is the correct value for the average speed of the motorcyclist? The choices are 1 meter per second, 10 meters per second, 15 meters per second, or 20 meters per second. Which of those will give the correct speed of the motorcyclist? One more answer to come in. All answers in. Let's see how you did. All correct. Well done. What that tells me is you didn't miss any conversions. Kilometers became meters, minutes became seconds. Really good physics. Well done. Next question. What is a typical value for the human reaction time? Choices 0.02 seconds, 0.2 seconds, 1.8 seconds, or 2 seconds. Sorry, that was the cat barging in. I'll put her on screen for a minute whilst you make your choices there. Which is a typical human reaction time? Let's have a look at. One more answer to come in. All answers in. Let's see how you did. All correct. I'm going to put Regs down now. Down you go, Regs. All correct. Good bit of knowledge. 0.2 seconds typical human reaction time. About 200 milliseconds. Next question. A car takes 5 minutes to travel 4 kilometers. What's the average speed of the car? Choices are 20 kilometers per hour, 24 kilometers per hour, 48 kilometers per hour, 60 kilometers per hour. One more answer to come in. Let's see how you did. All 4 answers in. All 4 answers correct. I was prepared to go through that. I found that one weirdly tricky. Just for a fraction of a second, I couldn't quite work out how to do the minute-hour thing, and then I thought, well, I'll just multiply up to find out how far it would cover in an hour, and I got there. Well done. You clearly had less trouble with that in a way than I did. So well done. Which of the following changes will not lead to an increase in magnetic field strength inside or around a conducting wire? Which will not lead to an increase in magnetic field strength? Choices: increasing the size of the current flowing through a wire, shaping the wire into a solenoid, increasing the amount of resistance in the wire through which the current is flowing, or adding an iron core to a solenoid to make it an electromagnet. One of those will not increase the magnetic field strength. Make your choice. All answers in. Let's see how you did. Really well done. Yeah, increasing the amount of resistance is the one. If you have more resistance, you have less current. If you have less current, that's when you have a weaker magnetic field. So really well done. Which pair of electromagnetic waves is most commonly used for communications? So there's 4 choices. There's radio waves and microwaves, X-rays and gamma rays, microwaves and X-rays, or infrared and ultraviolet. Now, which pair of those are most commonly used for communications? All 4 answers in. Let's see how you did. Very good. Now I'm just going to pause just for a minute. I think I'm going slightly crazy, but half of me was wondering through that is, have we skipped some numbers? We're up to 22, but I'm pretty sure the one before that was question 18. Well, I'm just going to scroll back. I don't think it's going to remove your answers, although I'm not sure. But if you also have been under the impression we've skipped some questions, then you can put something in the comments, I suppose. But I'm just going to scroll back, hoping that it doesn't remove the answers you've put. Oh no, I'm being entirely crazy. I must have, maybe there was some sort of time slip there, because I was certainly went from question 18 to 22. However, not a bit of it. No, that's all fine. So the next question, to question 23, sorry about that, is a ray of light passes from air into glass. The angle of incidence at the air-glass boundary is 30 degrees. Which of the following statements is true? Choices are these. The ray of light will speed up when it travels from air into glass. Or B, the ray of light will bend away from the normal when it travels from air into glass. C, the ray of light will speed up and bend away from the normal when it enters the glass. Or D, the ray of light will slow down and bend towards the normal. One of those is true. Make your choice. Let's see how you did. Split the room, this one. It is the last one. Because the ray of light slows down, I just want to show this as a diagram. It won't take long. It's just easier understood as a diagram, I think. So, we have, in fact, yeah, I'm not going to draw a glass block. I'm just going to draw a line. And I need you to understand that above this line is the air bit of this diagram. Below this line is the glass bit of the diagram. And yes, here comes the incoming ray of light. We were told that that was making an angle of 30 degrees. Now my diagram is more like 45, but it doesn't matter for this. Those angles are measured from the normal, don't forget. So you put in this 90-degree line, 90 degrees to the surface, and we call it the normal. So yeah, it went in and it was 30 degrees. So we were being asked, does it bend towards or away from the normal? It does bend towards the normal. Now, the reason for that is also linked in that question. It's because it slows down. So to really appreciate that, I'm just going to remove some of the detail from this diagram. To really appreciate that, you need to look not just at a ray of light, but at a wave front. So these lines represent the front of the wave. And I hope what you can see is that this side of the front hits the glass first. So this part of the wave has now slowed down, not traveled as far, so it curves up like that. I can carry on the diagram and the same thing happens here. And what you see is that the rays that emerge out of that boundary have a shorter wavelength. And that means they have a lower speed. The frequency hasn't changed, but the shorter wavelength means a lower speed. And so it slows down, but because it slows down this side first, it also twists towards this normal. It twists towards where the normal would be marked. I hope that's clear-ish. I think it is one of the harder things to get your head around. But yeah, the answer was that it slows down and bends towards the normal. Well done if you got it. Question 24. Which of the following is Newton's first law of motion? The choices are A, force equals mass times acceleration. B, forces that act on interacting bodies are equal in size and opposite in direction. C, work equals force times distance. Or D, a body will remain at rest or continue in a straight line at a constant speed as long as the forces acting on it are balanced. Make your choice. All four have answered. Let's see how you did. All four got it correct. So well done. I think at least one person has learned from a previous mistake there as well, which is always good. Next question, 25. Which of the following statements is true? A cup of tea at 90 degrees Celsius and a bath filled with water at 90 degrees Celsius contain the same amount of thermal energy. That, by the way, would be a ridiculously hot bath. That bath would kill you. Baths are normally, at the very most, around 41, 42 degrees. Anyway, there's that statement. There's a cup of tea at 90 degrees C emits radiation that is mostly infrared. We have C, objects that are at the same temperature emit the same intensity of infrared each second. Or we have D, the amount of infrared radiation emitted by a hot body does not depend on the nature of its surface. These are some complex ideas to get your head around. One of them is true. Please try and identify which. One more answer to come in. All answers in. Let's take a look. It was indeed B. Those who chose D, it does depend on the surface. You'll remember black surfaces emit more, even if they're the same temperature. A black surface would emit more than a shiny one would do. The one that was true is this idea that, yes, it emits radiation, something a cup of tea at 90 degrees. Not radiation we can see with our eyes, and most of that radiation coming off it is indeed in the infrared part of this spectrum. Next question, 26. Which of the following statements is not true? Forces that act at a distance from a pivot can cause a turning effect. The turning effect of a force acting at a distance from a pivot is called a moment. C, when calculating a moment, the force must be at right angles to the distance from the pivot. Or D, an object will rotate when the clockwise and anti-clockwise moments are equal. One of those isn't true. Try and identify which, please. Four students answered. Right, let's see how you all did. Here's the bottom one. If the clockwise and anti-clockwise moments are balanced, it won't rotate, it will stay still. It's like a seesaw. If the clockwise and anti-clockwise balance, then the object is in a sort of equilibrium, and so it won't rotate. Next question. Which of the following statements is not true for electromagnetic waves? They can all be reflected off a surface. They may be refracted when they pass from one material to another. They are all absorbed by the same materials by the same amount. Or they can be transmitted through different materials. Which of the following is not true? Again, make your choice. As you make your choice, again, I'm just checking that any of the emails coming in are not any of you. I'm just going to check that quickly. again, we're fine on the emails at least. Still waiting for people to make the choices here. And I can see why. I think there's a difficult one because perhaps this. One more answer to come in. Let's see how you did. Well, I expected that to trip some of you up. I'm impressed. Really well done. No need to go through that more. Next question. Which of the following statements is not true? A, there is an observed increase in the wavelength of light from the most distant galaxies. Sorry, not from the most, from most distant galaxies. B, the further away a galaxy is, the faster it is moving away from us. C, the further a galaxy is away from us, the greater the redshift. Or D, galaxies moving towards us have small redshifts. Which of those statements is not true? Lovely. All four have answered. Let's see how you did. Most getting it. Yeah, the further away a galaxy is, the greater the redshift. That's true. That's proof the universe is expanding. The further we look with our telescopes, the more redshifted the galaxies seem to be. But yeah, when a galaxy moves towards the observer, then the light gets squashed. It doesn't get redshifted at all. In fact, it gets blue shifted. It moves towards the blue end of the visible spectrum. Next question, question 29. A sound wave travels at a speed of 340 meters per second in air. If the frequency of the sound wave is 2000 hertz, then what is the wavelength of the sound wave? I'll give you a moment to do a calculation there. You can see your choices. Let's see what you come up with. Right, so we have all your answers. Let's see how you did. Half and half. I think I can see what must have happened. It depends which way around you divide these numbers. This is one where we have we have to employ the equation wave speed equals frequency times wavelength, which I'll write in its shortened form now. V equals F lambda. And then you put the numbers where you know them. Well, we know the speed is 340. And we know that equals a frequency of 2000 times by a wavelength lambda. Well, rearranging that, I suspect, is what a couple of you did wrong there. Lambda would equal 340 divided by 2000. And so the only plausible answer there is the 0 point something. If you're dividing a smaller number by a bigger number, the answer will always be arranged in the 0 point somethings. It will be a decimal. And in this case, it's 0.17. So well done if you got that. Final question coming up now. In what direction will the wire move below? Choices are left, right, inwards, by which they mean away from you and into the page, or outwards, by which they mean towards you, out of the page. In what direction will that wire move or experience a force? One more answer to come in, I think. And there it is, right. Well, let's see how he did. All came down to the left-hand rule. Most got it, not everyone. So, yeah, I'm sure you did employ the left-hand rule here, just incorrectly in one case. We know two things about the situation. We needed to work out the third. We know that the field is going north to south, so first finger field that way. We know the current is pointing down, so current that way. And that leaves the thumb pointing out of the page or out of the screen. And so in this case, yeah, the answer is outwards. And well done to the people that got that one right. Well, let's sum up. I am going to see how you all did now, but so are you. If I've done this right, you'll see your own answer. I'll turn the screen off just in case anyone's worried about what they got. So not everyone will see your answer, I don't think, but you will see your own answer. If I click finish now, and then I think I can see how you did. Right, 4 of you are playing along today, and we have scores of 90%, 60%, 83%, 87%. They are all very good scores. If we're going to do this slightly silly thing of applying grade boundaries to it, then my memory, I've not looked these up, my memory is we'd be looking at 3 9s and an 8 there. Clearly this is not a proper GCSE, although weird to think you would have been doing proper GCSEs at this very moment. What a strange year you are living through. But that's certainly our second quiz, and you've all done really well on that one again, really well. So I think what I'll say is my goodbyes at this point, which doesn't mean for a minute, by the way, that you can't get in contact with me for whatever reason you wish. So it could be that you need help making choices about A-level. Whatever is going to happen with GCSE results, we still sort of don't know, although it's becoming clearer, but results day will happen on the usual day. And if that leaves you with choices to make, then please be in contact. You'll hopefully see me on results day. We'll see what kind of world we're living in by then, but hopefully you'll see me on results day. But aside from that, if there's anything at all with which you need help, then please do get in contact. And if there's anything physicsy you want us to answer, like just a general query, if there's any books you want me to suggest for reading before A-level physics, if there's anything of that sort at all, then don't hesitate to get in touch. But the last thing I will say is just another massive thank you for, and it feels such a long time ago since I saw you all now in a strange way, but for sticking with it, for wanting to learn some more physics and wanting to see the course through. And it says a lot about each and every one of you. So for now, I will say goodbye. Enjoy the rest of your day and your weekend. Continue to stay safe and stay sensible, even as things are beginning to open up. Keep yourself safe, and goodbye for now. See you.